Okay, so in our last lesson, we spoke about the basic terminology of algebra, and we also learned how to identify coefficients, terms, and constants. So we've gone through the first two learning intentions. What we're going to be doing today in this lesson is going through our final learning objective, which says to be able to write expressions from word descriptions. So let's come all the way down to this page right here. Okay, so let's begin. The first thing we're going to do is, once again, learn just a little bit of terminology. And that is, when we're writing expressions from word descriptions, we're going to have to know certain words. The first one is going to be the word sum. If I say the sum of A and B, what is that mathematically, the sum? Well, the word sum means just add. So the sum of A and B is just A plus B. Let's move over here now. Another word, which is probably a lot less familiar to a lot of you, is the word product. If I said, what's the product of A and B? The word product means multiply these two things together. So A times B, which is equal to just AB, because remember, we don't like putting that multiplication sign in. So when we say the product of AB, it's just AB. All right, next. Write expression for each of the following. Alrighty, so we're going to first go through some addition examples right here. It says 5 more than K. Well, 5 more than K means we're going to go 5 more than K. So we're just going to plus 5 to the K. Now, it's also important to realize that with addition, the order doesn't matter. So we could say or 5 plus K. It actually doesn't matter which way you do it. And let me just prove this to you for a moment. Let me come over here. You don't have to write this down. But let's just say we had K plus 5. Let's let K equal 2. So 2 plus 5 is equal to 7. Well, what happens if I had 5 plus 2? What's that equal to? Well, that's also equal to 7. So the order does not matter. So we can come over here and we can say for addition, the order does not matter. All right, let's keep on going. The sum of A and 2, well, that's just A plus 2, or 2 plus A. Next, the sum of A and B, that's A plus B, or B plus A, because the order does not matter. Okay, let's now go through some subtraction examples. So right here are some subtraction examples. Subtraction. And these are the ones that really get people. So it says 3 less than M. Let's read that carefully. 3 less than M. That means you're starting with M and you're taking away 3 from it. This is now 3 less than M. Now, lots of people are going to read this and they're going to go, well, 3. So they put down a 3. Then they go less. Well, that's subtraction. Then they see M. So they put it like that. And as you can see here, what makes these two things different is the order. So now the question is M minus 3 the same as 3 minus M? Does the order matter for subtraction? We know the order doesn't matter for addition, but does it matter for subtraction? Well, let's give it a go. We have M minus 3 and we have 3 minus M. If I said, let M equal 5, so that means I'm going to come here and I'm going to put 5 there. 5 minus 3 is equal to 2. Okay, well, let's come to our other one in which the order is switched, and we're going to put a 5 here. What's 3 minus 5? Well, 3 minus 5 is going to be negative 2. These aren't the same. They are not the same. So that means when we come over here, this is not the same as that. So therefore, this is wrong. This is wrong. You have to write it like this. 3 less than M is M minus 3. Okay. That's very important. So for subtraction, the order does matter. You have to be careful with the order when you are doing subtraction ones. Okay, let's do the next one. M less than 3. So that means 3 minus M, because it's M less than 3. So taking M away from 3, not the other way around. 18 is subtracted from H. So that means we're starting with H and we're subtracting 18 from it. So remember, the order is important here. You can't do these the other way around. 18 is subtracted from H. Okay, let's keep on going. Next, we have multiplication. For multiplication, it says double the value of x. Well, that's simply going to be x times 2. Now, that's the same thing as 2 times x, right? So we can say that the order does not matter, right? Does not matter. Because for multiplication, if I went 3 times 4, that's going to be equal to 12. And if I went 4 times 3, that's also equal to 12. So we know the order doesn't matter for multiplication. But remember, with algebra, how do we write this algebraically? Do we put in the multiplication sign? No, we do not. We just write it as 2x. And remember, we have a coefficient, and that number always goes in front of the pronumeral. So even though we're saying the order does not matter mathematically, algebraically, you do have to make sure you write it like this. So I'm going to put a little asterisk here, which kind of denotes that fact, that there is kind of an exception here. Because the product of CD, well, that's just C times D, or it's D times C, but the way that we write it is CD. You could write it as DC if you wanted to, but most of the time you write it in alphabetical order. All right, let's keep on going. Next, triple the value of x. Well, that's just going to be 3x. No mucking around there. That's your answer. 3x, 3 times x, that's what it's going to be. All right, next, division. The first one is t is divided by 5. So this is t is divided by 5. Now, remember, we don't like putting in division signs. We would write this as t over 5. That's how we would write it, t over 5. Now, you might be asking the question, is that the same thing as 5 over t? Are these the same? All right, so let's come and let's do an example. So we have t over 5, and we're trying to figure out whether or not this is the same as 5 over t. Well, let's just say let t equal 10. If t was equal to 10, that means I'm going to take this t and I'm going to put a 10 in there. In this case, I'm going to get 10 divided by 5, which is 2. If I was to put a t here, a 10 here, 5 over 10, that's a half. These are not the same. They're not the same. So that means that is not an answer to the question. So for division, the order does matter. So you need to remember that subtraction and division, the order does matter. And you also need to remember that for multiplication, while the order doesn't matter, you still have to make sure that you use those algebraic conventions of the coefficient. Okay, let's keep on going. Half the value of z. Well, that means z divided by 2. But there's also another way we could write this. We could say or half times z. Because if you time something by a half, that's the same as dividing it by 2. And remember, we don't like putting that multiplication sign, so you would just write it like that. And let's come over here, 1/9 of m. So that could be m over 9, or you could say 1/9 times m. They both give you the same answer. So whether you're dividing or you're timesing it by a half or 1/9, you're going to get the same answer there. All right, let's keep on moving. Expressions involving more than one operation. So the instructions here are to write an expression for each of the following without using the multiplication or division sign. And as you can see here, we have more than one operation going on. So here we have p is halved, then 4 is added. So I'm going to half p, so it's going to be p divided by 2, and then I'm going to add 4 to it. So that would be my answer. Now remember, p over 2 is the same thing as a half of p, so a half times p plus 4. So there are two different ways you could write your answer. Next, the sum of x and y is taken and then divided by 7. So we have two things going on here. The first thing we have going on is the sum of x and y. So that's x plus y. And now what we want to do is divide this whole thing by 7. Now here's the really important part. We can't just go divide by 7. The reason why, because of BIDMAS. BIDMAS tells us that we would have to do the division first in this case, right? We would have to go y divided by 7 plus x. But based on this word description here, what we first want to do is this x plus y. So that means we're going to have to put brackets around this sum. And then that tells us first go the sum of x and y, and then divide by 7. Now, remember, we don't like putting in the division symbol. So the way that we would write this is go x plus y over 7. That's how we would write it. That is your final answer. X plus y over 7. And that's saying x plus y first, then over 7. When you write it in this form, you don't need the brackets. You don't need to put brackets here. You can if you want to, but they're not necessary. Whoopsie daisy. Whoopsie daisy. That's your answer. Okay, next. The sum of x and 1/7 of y. So that's going to be x plus y divided by 7. Or the other way you could write this is x plus 1/7 times y. Both of those are acceptable. And let me just write this a bit nicer. Okay, perfect. Let's keep on moving. This tells us 5 is subtracted from k and the result is tripled. Okay, so the first thing we want to do is 5 subtracted from k. So we're going to start with k, we're going to subtract 5. And now we want to triple this result. We have to be careful. This is very similar to what we did up here. If we just go multiply by 3 here, because we're tripling, what this is saying is -5 or 5 times 3. Because remember, BIDMAS tells us we have to do the multiplication first. But reading this tells us we first want to do this subtraction and then triple it. So we're going to have to put brackets around it. This is what it should look like. Then we have to remember our algebraic conventions. We don't like putting in multiplication signs. So the way that we answer this is like this. So we've got this 3 times what's inside here. And we always put the number to the front. Just like our coefficient, the number is at the front. So this is our answer. Next, 3 is subtracted from the product of PQ. Okay, 3 is subtracted from the product of PQ. So we have to be careful here. So we've got the product of PQ. So we know that's just going to be PQ. And from that product, we're subtracting 3. So 3 is subtracted from the product of PQ. Okay, let's keep on going. 5 less than m is multiplied by 7. All right, so we've got 5 less than m. So we've got m minus 5. And then we're multiplying this whole thing by 7. So that means, remember, we don't like writing it like this. We're going to put that 7 at the front, then m minus 5. That is our answer. All right, let's keep on going. So here it says describe each of these expressions in words. So we're kind of doing the opposite of what we did up here. Here we took the words and put it into maths. Now we're going to take the maths and put it into words. All right, so we're kind of going to follow BIDMAS here. We're going to look what's inside our brackets first. So we're going to do k plus 3. So we're going to say the sum of k and 3. And then we're going to multiply it by 8. So we're going to say the sum of k and 3 is multiplied by 8. Okay, let's keep on going. Here we have k minus 3. And remember, even though there aren't brackets there, we know that we're doing this subtraction first. So we're going to say this right here is 8 less than k, and then we're going to divide it by 20. So 8 less than k is divided by 20. Pretty easy. And then the last one, we have 4 minus xy. All right, so we're going to say the product of x and y is subtracted from 4. So the product of x and y is subtracted from 4. So the product of x and y is subtracted from 4. This is 8 less than k is divided by 20, and this is the sum of x and y. X and 3 is multiplied by 3. Perfect. All right, that is everything. We have now worked through all this information. So a lot of information there. Hopefully you found this useful. And yeah, you can now begin exercise 5A. Exercise 5A. All right, I'll see you in the next lesson.